We start with lesson 7-1, solving linear systems by graphing. Turns out in a lot of business applications and science applications, we have two sets of data. We want to know where they intersect. So the best way to start this is by looking at it graphically. So let's graph the following two and see where they intersect. 2x minus 3, down 3, and up 2 over 1. And now I'm going to do something that I don't usually do. I'm going to go up 2 over 1, up 2 over 1, and I'm not going to connect my dots until I graph the other one. The other is up 2, 1, 2, down 3 over 1, 1, 2, 3 over 1. So I can see that they hit at this same point here. That's the whole point of graphing, is you're trying to find out where they hit, and it can be very challenging if you just throw a line up there and pray that it works. So we figured out the hit here, which is the point 1 comma negative 1. That's where they intersect. Now, looks like we did the graph, but are we sure that they definitely hit there? How do we know for sure? We put them in the original equations. And make sure they work. I'll call this checking. And you should always check. It does not take long. It's a quick process to make sure you get it right. So, we got x is 1, y equals negative 1. So let's try the first equation for the check. Negative 1 equals, or does it, 2 times 1 minus 3. 1 equals 2 minus 3, negative 1. Get rid of my question mark, put a little check next to it. And let's try this one. Negative 1 equals negative 3 times 1 plus 2, question mark. Negative 1 equals negative 1, check. So it looks like it works. Try another one, see that we know what we're doing. Of course, the challenging part is putting it into the y equals mx plus b form first. By now, you should be old hat at this. If not, it's not that hard to redo it. Get the knack back. So y equals negative 1/2 x plus 7/2. 7/2 is 3.5. 1, 2, 3.5. Negative 1 over 2 means down 1 over 2. Down 1 over 2. Down 1 over 2. And as I just said before, we're going to not fill in the line, just leave the dots until we're confident. So here we go again. So we get y equals 3/2 x plus negative 5/2. Negative 5/2 is negative 2.5. 1, 2 here, and 3/2 goes 1, 2, 3 up over 2. 3/2. 1, 2, 3 over 2. Yep. Up 3. 1, 2, 3 over 2. And it would appear that they intersect at this point right here. Hard to tell for sure, but it looks like 1, 2, 3 over and 2 up. 3 comma 2. Let's check just on one of them. Always go back to the original equations. You may have made a mistake. So x equals 3, y equals 2. 3 plus 2 times 2 equals, hopefully, 7. 3 plus 4 is 7. We really want to be thorough. We could check the other solution, but that should do for now. Now that was graphically. Graph's nice. You can do it fairly quickly, but if it's not a perfect point, it's impossible to get a precise answer. So here's the second way we're going to try. It's called substitution. And we've set it up for you here with these two equations. And this is the equation we want to look, because we have to write one equation as y equals or x equals. So that's our y equals 2x minus 3 equation. Now we take that's saying what y is. We take the 2x minus 3 and we put it in for y in the other equation. So we will get 2x minus 3, taking this whole equation down here, plus 3x equals 2. It seems a little bit confusing to people. So again, here's what we did. We took the 2x minus 3, we put it in where there was y, and we rewrote the equation. So 2x minus 3 for y, that's 2x minus 3 here, plus 3x equals 2. Now we've got an equation with just one variable, so we can solve it. 2x minus 3 plus 3x equals 2. Add 3 to both sides. 5x equals 5. Divide 5. X equals 1. Once we have one equation, we can just plug it in to get the other one. So we'll use the y equals 2x minus 3. It does not matter which one you use. Y equals 2 times, we know that x is 1, minus 3, y equals 2 minus 3, y equals negative 1. So there's our solution, 1, negative 1. We should check, and I almost always use a different color to check in my notes, so hopefully you can pick up on that. We have to use the other equation now. So we just use this to solve, now we use this to check. Y plus 3x equals 2. Y plus 3x equals 2. Let's check it. Negative 1 plus 3 times 1 equals 2. Negative 1 plus 3 is 2 equals 2. Looks like we did it right. After you've done this a few times, it's not that challenging. It is a bit time consuming, but you do get a precise answer. You could have graphed these and gotten the answer nice and easily because it's at an easy point to understand, but it's not always going to be. As a matter of fact, usually it won't be, although us math teachers generally are kind of nice about that. So which one do we want to sub in? Well, obviously this one it's already solved for x, so we'll put it in right here. Get 3 times negative 2y plus 7 minus 2y equals 5. Negative 6y plus 21 minus 2y equals 5. Subtract 21 from both sides. Negative 6y and negative 2y is negative 8y. Negative 16 divided by negative 8. Y equals 2. Plug it back in. Doesn't matter which one, but looks pretty nicely set up here. For x equals negative 2 times 2 plus 7. X equals negative 4 plus 7. X equals 3. Don't like my 7s. So there we go. Solution 3, 2. We're not done. So we check, which is nice. We should never get these wrong on a test. We'll use this one. 3 times 3 minus 2 times 2 equals 5, hopefully. 9 minus 4 equals 5. 5 equals 5. It checks. So there you have it. Get to work. Lots of practice. Not that difficult, time consuming, and very detail oriented. You'll find the wrong answer a lot when you finish these problems. You have to go back through your notes, so write them all out like I've done here and find out where you made your mistake. Good luck.